In this video, we're going to look at extending our gold mark and adding the functionality to parse an aside, something that looks like this. And it's basically just going to be a little block that has a title and a closing block. And then inside of it, we want everything to be parsed exactly as it normally would be with Markdown. And we want it to generate HTML that kind of looks like this, where we have the aside tag, we have an H3 for a title, but everything else inside of this is being rendered exactly as it would be for normal HTML. So before we get into this really far, I guess what's worth saying is that you can skip this video, especially if it feels like it's too cumbersome or it's too much or it's just confusing. We're really going to have to dive into the Goldmark library specifically, and we're going to have to look at a lot of interfaces that are there and figure out how to actually extend it. And for a lot of people, that's just not going to be information that is super useful. Maybe watching my process for doing this might be useful, but even then, realistically, when I went about doing this and figuring it out the very first time I ever extended Goldmark, I had to look at a lot of source code there to sort of figure out how their extensions work and what that stuff is like. So there's going to be a lot of like just digging that's kind of boring, not very interesting to show in the video like this. So it's not all going to be there. I will do some digging in the video to look at the obvious stuff, but there's some things that the first time I went through and did something like this, it took a little bit of time to find. That now that I know about it, I can get there a little bit quicker. So just keep that in mind that if you're doing it on your own, don't expect it just to be like a quick magical process where you find everything perfectly. Sometimes you just need to go dig for example code and example extensions, which luckily Goldmark has some good examples of extensions and different parsers. So that makes life a little bit easier. The other part of this is that we need to learn about and understand how abstract syntax trees work, which again is something that you may or may not care about. So I guess we'll just talk about that. So like I said, we're going to be parsing this aside, and we're going to be trying to turn it into something like that HTML that I was showing you here. And the way that we do this is that Goldmark uses an abstract syntax tree, or an AST. And we can see this by looking at the Goldmark library, hopping down here, and seeing that it's AST-based, preserves source positions of nodes. Just basically the AST-based is all you have to know. And if you look at the source code, there's an AST package that clearly has some of the different stuff about it. And if you start looking at the parser and some of the other stuff, you'll realize that it is abstract syntax tree based. So what is an abstract syntax tree? I guess I should go here to show you. First off, if you don't know, there's some Google videos out there or YouTube videos and others out there that are worth checking out just to get a better understanding. But the short version is you can take content like this Markdown on the left, and an abstract syntax tree is essentially just a way of turning it into a tree structure that has a root node, and then every node has children or can potentially have children. And each child has some sort of different type. And what you're really trying to do is you're trying to take something complex like a Markdown file or maybe a source code file or an HTML file or whatever else. HTML is probably the easiest one to understand. So like you can see here that the HTML is the opening and closing. Each child is going to be this body tag. And then inside of this body tag, it's going to have an H1 child and a paragraph tag. So if we come over here and look at the left-hand side, you'll see that here we've got, I don't know why it's called type program, but anyway, we have this whole thing here that's the HTML tag. The HTML tag has children, and inside of its children, it's got 3 elements. I don't know why it's got 3, but you can see here we have the body. Then the body has some children, and the children inside of the body are going to end up being element 1, which is the H1, and element 1 again. Well, I don't know why it's named that, but it's fine, which is the paragraph. So there's different like children that are inside of there. If we go back to the Markdown, you'll see here that we have the root is just the whole document, and then the children are the heading, the paragraph, the thematic break, the code, and the list. And each one of these children can have their own children. So if we click into the paragraph, it can have text, emphasis, bold text, all these different things are in here. And the reason this is useful or it's beneficial is that, one, we can write parsers for each one of these things individually. So we can have a parser for emphasis text. We can have a parser for strong text, a parser for inline code, a parser for code blocks like this. And then with all those parsers, we can take a very complex document like this Markdown file, and we can just run through every time we're looking at a new line or a new bit of code, we can say which parsers could actually help us here. And as we go through like this paragraph, well, we might look at this first bit of text and be like, okay, can anybody parse this? And then if not, it just becomes text. And then we get to this emphasis and it's like, okay, can anybody parse this? And the emphasis parser might be like, oh yeah, I can parse that. That's actually italic text. And then as you progress, like this right here might get parsed by the strong parser, and this might get parsed by the inline code parser. So you have different parsers that are each doing their own job, and they're essentially looking at text and deciding, can I parse this or not? And then they parse the bit that they can, and they tell the rest of the AST parser to continue on with, whatever other parsers and stuff it needs, and this is how much of the text I consumed and parsed. So basically what this allows us to do is it allows us to take really complex documents and turn them into this tree structure that has all these different kinds of nodes in them that are all parsed into a specific type. Then the other benefit to this is that when we want to render this into something like HTML, we no longer have to think about parsing this complex document. All we have to do is say, if I have emphasis text, how do I render that? Or if I have strong text, how do I render that? And in all these cases, it becomes very easy because we're saying, like, strong text is easy, you put a bold tag around it. Emphasis text is easy, you put an italic tag around it. Same with inline code and all these others. They tend to become a lot easier to parse. So it doesn't matter how complex the markdown is, as long as we have it into an abstract syntax tree, we can render the whole thing by just going through a list of all the different things that are in it and figuring out how to render them. So I have here, this is just like another representation of that tree so you can see it without all the extra text that gets thrown over here, where you could have a root node, inside of that could have a heading, a paragraph, and the paragraph might have a couple different things inside of it. Might have another paragraph that just has text or whatever. You could have a code block. You could have a list with some list items, and each list item might have some paragraph with text, or might have something else in it. So you can see that this can be a very, very deeply nested tree, but as long as you go from the whole tree in order, you should be able to render that whole thing into whatever format. Another upside to this is that we can take the rendering and we can actually add custom renderers, and that's actually what's happening in our application when we do, if I can find it, this highlighting, is it's basically just taking the renderer for our code and it's replacing it with a new renderer that's going to know to use syntax highlighting. So again, we can like sort of style things differently. We could even theoretically go through and change all the renders for our gold mark so that it actually keeps things like this hashtag and these emphasis things. So you can see how this is actually rendering all of our markdown, but it's rendering it as markdown even with the the actual looks of what markdown would look like. So that's something that we could do later if we wanted, and some people might like that since this is like a tech blog. Okay. So now that we know it's an abstract syntax tree, I guess the one last thing I want to say before we move on is if learning about an AST or just ASTs in general interest you, Thorsten Ball has a book called Writing an Interpreter in Go. It has, essentially you take a programming language and you write a parser for it, and in the process you will create an abstract syntax tree. So if that's something that you're interested in, this might be a book that's worth checking out. Okay, so going back to our Goldmark stuff. We need to figure out how it works, and we need to sort of figure out how to extend it. There's a couple ways to do this, but if we look here, we'll see that we're already calling it with an extension. So we just need to find a way to add our own extension in here. And if we dig into that source code, you'll see that we need something that implements the extender interface. And that's just an interface that has an extend method that takes in this markdown. So we can come back, we can just go to our editor, I guess, and code aside.go. We'll tell package golb, and we'll just do type aside block extension struct. And then we will do func, let's do ext aside block extension, and we'll do extend and this is going to be goldmark.markdown. So we save that, and now we need to figure out what are we doing with this goldmark.markdown. And you can see here, since I have Copilot, it's going to go ahead and just try to do some of this for me. But if we were to go back here and look at the Goldmark library and look at some of the extensions, the one that is probably worth checking out first is the footnote one, just because it has a lot more to it. But this footnote one, if we find the extend method, you'll see here that it calls m.parser.addOptions, and it's adding a bunch of options. We won't need all these, but it's adding a lot. And then it's also calling m.renderer.addOptions. So these two things are the key parts. We need to add a parser, and we need to add a renderer. And in our case, we're going to want a block parser. There's block parser, inline parser, and then you can see here they have AST transformers. There's other things you can add, but a block parser is going to be what we need for something like an aside block or a code block or something that's actually a block that has like an opening and closing and has some stuff inside of it. So we're going to go ahead and just copy this bit here. Actually, let's just copy all of it and we'll just trim out what we don't need. Okay, so I want parser with block parsers. I'm going to comment this out because this isn't the parser we want. We don't need any of these other things, so I'm going to delete them. And then I'm again going to comment this out, but we'll leave it there so we have it to reference. So we need to add a node renderer and we need to add a block parser. And that's because we're going to be adding nodes of the aside block into our abstract syntax tree. So that's what it calls every item inside of the AST is just a node, and we need to add a renderer for it. And I'm going to move that to the same line. Okay, so with this, we want to add, you can see here, this is a new footnote block parser. We want to add an aside parser. So we'll do a type aside block parser. And we're going to have a type aside block renderer. And we're going to add both of these two into these two things. So here we would just be doing aside block renderer. And here we're going to do aside block parser. And then these last numbers are the priority of this that's being done. I'm just going to do 500 for both. I don't actually know. I don't even know if the priority is supposed to be like highest goes first or lowest goes first. In our case, it really shouldn't matter, but I'm just going to put 500, which hopefully is somewhere, I'm assuming it's from 0 to like 1,000 is kind of the typical range based on that 999. So I'm just going to stick it in the middle and it should be fine for now. Later, we could sort of tweak these if we were trying to like fine tune our performance, because you don't want your parser to be called to try to look at something if, you know, there's a lot of other ones that are more likely to actually be correct. But at the same time, if somehow the same character could be used by two different things and you need to make sure one of them happens or tries first. An example of this could be, this is italic text and this is bold text. There could be an argument for having the bold text parser run first, because if it's not bold text and you see a star, you can just automatically assume this is italic text, so you don't actually have to like check quite as much. So that's one case where maybe that would matter. I don't know if that's how they actually did it, but that's just one thing to consider. You'll notice here that our code is not erroring, and that's because this prioritized function, I don't love this, but it just takes in an interface and a priority. So because of that, it's not really clear what we're supposed to be doing. So what I ended up doing is I ended up looking at some of the existing code, again, like this one, and I'm looking at like what is happening with these parsers or how they're being done. And we can go to the new footnote block parser, and you can see here that this is returning a parser.block parser. So that's what we want to do, is we need a parser.block parser. And if I go to the block parser interface, so block parser is used to, like I said, do block level elements like a paragraph or a list or a block quote. Whereas if we scroll down here to the inline parser, that's going to be like a link. So we need this block parser. So we want to go ahead and make sure that we're implementing that interface. So we're going to do var underscore, this is, which package are we in? Parser? Okay. Parser.block parser equals aside block parser. Okay, so what I'm doing here is I'm using the empty variable, and I'm giving it the type parser.block parser, and then I'm assigning it to our aside block parser type. And I'm doing this because it's now going to give us an error whenever we are not implementing some of the interface methods that we need. So this is going to tell me, hey, we can't use this for this type because it doesn't implement the correct methods. Now that I have that, I'm going to go ahead and generate the interface stubs and see if we can get rid of that error. So I'm going to go ahead and pull up, I'm going to use the VS Code tools for this, but you could probably do it another way. And I think most Go editors will probably have some way of doing this. So we're going to generate interface stubs. So for here, we are going to do P for the parser. We're then going to tell it the type aside block parser. If you wanted this to be like a pointer receiver, you would put the star in front of it. And then we tell it what interface we want to implement. So it's going to be parser.block parser. All right, you'll see here that it's generated all of the method stubs, and it's also copied over all the comments, which is really handy because now when we go to implement these, we will actually know what it's supposed to be doing. And if somebody else reads this code, they'll know what it's supposed to be doing. So I'm going to save this. One thing that I'm going to note right now is that if you're saving with autocompletes, you might want to check the autocompletes, because right now it's pulling in, apparently the Go standard library has an AST package, but that's not the one we want. We want the Goldmark AST package. So I have that import now added, and it should get rid of our errors. So this is no longer erroring. And we have all these methods here that we need to implement. So with these methods here, there's a couple that we need to look at. basically the way this is going to work is trigger is going to tell it characters that we are looking for, like the very first character that might suggest that our parser needs to run. In our case, it's just going to be that colon character. Open is going to be used to basically we'll be given a line. If trigger is something that is correct, like matches, it'll then pass that stuff into our open that'll say, hey, can you parse this line? Is this something you should be parsing? And what we're going to do here is we're going to look at it, and if it is something that we can parse, we're going to return a new node, and we're going to tell it whether or not it has children that need to be parsed. And then if it has, I'm pretty sure if it has children to be parsed, it'll then go into continue. And continue is where we're going to be looking to see, like, is this something we should be parsing? Or, like, for instance, the close of our aside block? Or is it something that should be parsed by a different parser for every line that's coming afterwards? So we'll do all that, and then eventually it'll finish whenever the parser returns, and this close function will be called. I don't think we actually have to do anything inside of close because we don't have any like wrap up or clean up stuff to do. As long as we get to the continue and we know we're at the end, we can tell it that we don't continue anymore, we're done. But I think that's all we have to do. Because I think here, if continue has not been able to parse the current line, continue should return close. If continue has been able to parse the current line, continue should return continue no children or continue has children. Yeah, so in our case, when we get to the very end of our aside block, we can tell it to continue, and we can tell it we don't have any more children, and it'll stop parsing from that point. I think that's when it will call close. Or I take that back. Maybe this is being called, but we aren't going to worry about that. Okay. Can interrupt paragraph. This is just an option to, like, if your parser could happen in the middle of a paragraph. Can't accept indented line. This is just if you want to accept something that's indented. We don't care about that. So here we can return false. We can just get these easy ones out of the way. Can't interrupt paragraph, return false. And I think this one is no op. All right, so let's go up here and let's start with the trigger. This right here, I said we want to return a byte slice of all the characters that could potentially start off our parser. And in our case, we only care about things that start with the triple colon. So the first character in that sequence is going to be the single colon. We don't need to return 3 of them because this just wants individual characters to check for. This next part is open. This is where we actually have to start getting into, the nitty-gritty of actually implementing things. So what we want to do here is we want to maybe look at another function to see how it's doing this. So I'm going to go ahead and copy some of this code. And I'm going to go up top. Actually, let's just go to parser. And let's do... Okay, so there is an open function in here. This is the fence code block parser. There's a couple different parsers that are in the standard library, or in this, not standard library, in the Goldmark package, and then there's a couple extensions. So there's a couple different places we can look to get an idea of how this should be done. But you'll see here that this is going to call reader.peakLine. Most of the opens do this, and then they will look at the current line, see if they can parse it, and if they can parse it, they will advance the line, because that's what you're supposed to do according to the docs. Open must advance a reader position by the consumed byte length. So yeah, if we can parse it, we will advance the reader, but we're going to use peak line so that it doesn't advance the reader automatically. We're just looking at the contents without actually telling it to fully advance. So we'll do that. We'll do line segment. It's going to be reader.peak line. And then what we want to do here is we want to actually check to see if this is going to match what we want. So if the length of the line is less than 3, we're going to return nil, parser.noChildren. So what's happening here is we're saying that if this line is less than 3 characters long, there's no way it can be the open to an aside block because we need 3 colons to open an aside block. We're also going to say if not bytes.equal line 0 to 3, and we don't really need the 0, and we're going to compare it to the byte slice. We're just going to convert that string into a byte slice using this syntax. So if those two things are equal, or if they're not equal, we're going to return nil, parser.noChildren. So this is what happens if something doesn't match, we always return nil, no children. So in both these cases, we're saying if it's less than 3, or if it doesn't start with colon, it's not a match. So we're going to return nil, no children. But as long as those two things do happen, we are going to return... we need to return an ast.node of some sort, so we need to figure that out. And then we're going to return the parser.state. So we're always going to return parser.hasChildren. And then the other thing I forgot, which I mentioned earlier, is we also need to advance the reader. So to reader.advance length of the line. And we're not using segment, so I can get rid of that. So for now, I'm going to put nil here. And then I'm going to put a to do replace nil with a node type. So we need a node here to return, and that's just so we have like a node that represents our aside block, something that can be stuck into the abstract syntax tree, and then when we come to render it later, we can do that. So that needs to be of the type ast.node. So we can look at that, and that is quite the lengthy interface. Okay, this does have that. Okay, so a lot of times in an interface like this, when it has a ton of methods, what you should look for, or sometimes you might want to look for, is that it might have a base node or something like that that will implement a lot of it for you. And this exists because in most cases, people want the same functionality for a lot of these functions, but it gives you the option to override some of them if you need to for some reason or another. In our case, we're going to use the base node and the ast.node to help us implement the ast.node interface, and then we will add whatever methods we need custom. And then if we do need anything custom down the road, we will come back and tweak it. Okay, so I need to add a new type. Let's just add it right here. We'll do var aside block node struct, and this is going to be ast.baseBlock inside of here to give us the methods that we need. And I'm going to do ast.node is going to be equal to aside block node. All right. I'm not sure. ast.baseBlock is not a type. Did I get this wrong? Oh, it's base node, not base block. Just typed it wrong again. Okay. I'm not sure what it's complaining about right now. I'm clearly doing something wrong. All right, variable of type struct ast base node is not a type. Oh, it's supposed to be type, not var. Sorry about that. All right, so this is now going to give us an error that's basically saying that we can't use this because it doesn't have the method dump. So we need to do, let's just do it, func n aside block node. And this, I'm lucky enough that it's auto-completing this for me, but I could come back to the, where is it? The node stuff and look and see what these methods are. So you'll see that there is a dump in here. And then what's the other one that we need? Doesn't have the method has blank previous line. Func n aside block node has blank previous lines. I don't think it matters if we have blank previous lines. We don't have is raw func n aside block node is raw. I don't know what that actually is, so I might need to go dig that up. I feel like I messed something up at this point because I mean, maybe I need all these, but it just seems like that's a lot that we're having to do. So what is raw supposed to do? All right. If the content should be rendered as raw contents. Okay, so, well, we don't want that. Has blank previous lines. Again, we could have also, like I said before, we could have done that stub interface generation. I intentionally didn't do this because I didn't want all these methods being added, but you could do that and then remove the ones that you don't want. All right, returns true if the row before this node is blank, otherwise false. I don't care if it's blank or not in the row before, so we'll leave that there. What other one do we need? It's missing kind. Func n aside block node kind. And we need a node kind. So that's like an int. I'm guessing there's, okay, new node kind. So we just need to call this and add a new type. So what we'll do here is we'll do something like aside block node kind equals ast.newNodeKind aside block. And I only want to call this once because I don't want it to, if you look at the definition of newNodeKind, it's iterating the number of different kinds it has, and I want these all to be using the same one. So I'm going to go ahead and just declare this as like a global variable inside of this package, and I wouldn't have to export it if I didn't want to, but I'm going to leave it exported for now. And I'm going to go ahead and just return it here so everyone's using the same one. It's missing method lines. What is the method lines? It's only, so I'm a little bit, I feel like it's having us implement a lot of these. I assumed that the block node was going to cover a lot more of these. So I'm wondering if I did something wrong. Let's see what any of these are doing. Let's go to the open. New fence block. Let's get the fence code block type. It has base block inside of it. Did I import the wrong one? That's what has me confused. No, this has base node in it. Okay, so that looks right. If b.lines equals nil, where's lines coming from? I'm just trying to see if this base node has any of these methods in case I'm adding things I don't need. Well, I don't see the lines one, so we're probably okay. But I will definitely say that I'm curious. I feel like I wanted to use this base block type because it looks like it has even more of the stuff. The base block struct implements the node interface partially. I'm willing to bet that the base block one is for like a block that we're parsing instead of like an inline block parser. It's just like a regular parser. So that's probably what we wanted. It's probably why we're having to implement way more than I expected. Okay, so that got rid of a lot of our errors. Not sure why it wasn't working before. I don't need is raw, and I don't need this. I do need dump. I know that from doing this in the past with different projects. I can see here if I get rid of it, it's going to give me an error. But I do know that dump is a little bit easier. So I apologize. What just happened was I was importing base node, and it looks like there's a base block type as well that's being provided by the AST package. And base node has like maybe 50% of the functions inside of the node type, and then base block adds like another 4 or 5 of them on top of it for somebody who's parsing a block. But it doesn't have the ones, it only has the block ones. So I wanted the base block, not the base node. And then where are we at here? I need dump. So I need to figure out how dump is being implemented in some of these, because I'm pretty sure, yes, I'm going to copy this code. I was pretty sure there was a dump helper from whenever I was digging through all the code and figuring out how this worked. So what this appears to do is you normally create a map that has any information that's specific to your aside block, and then I don't need this bit, and then you call the, I think it's ast.dumpHelper, and you pass in all of this information. So you pass in the node, the source, the level, which is like the indent level, and then the map that you want to do, and this is just like a debugging thing. It's going to make debugging a little bit easier. And now that I'm here, I'm actually thinking for our aside blocks, if we look at what they look like inside of code, we want it to have a title up here. So it might make sense to parse that title into this aside block node. Because otherwise, getting it to parse as like a heading tag is going to be annoying because it doesn't start with it. And I don't want to have to... I mean, I could make it this syntax where like you could do it something like this and try to make that work, but I don't want to try to do that. I just want to always have it be consistent. So I'm going to go ahead and just do that. And then here, I'm going to do end.title. This needs to be a string. Okay, so this will allow us to dump some of that stuff out. If you don't know what this is doing, don't worry about it. This is all, the dump part is just for debugging. The kind part is the only important thing here. And really what the kind is doing is it's allowing us to define our node kind that's inside of the abstract syntax tree. And then later, whenever we go to render, we're going to have a renderer that registers something that says, hey, if you do happen to get this aside block node, call this renderer that I'm writing right now. Okay, so now that we have that type, we can come down here to our open function, and we're going to return a side node or side block node and the parser that has children, except we need a title here. So this is going to be line from 3 onwards, except I want to do strings.trim. Let's do trim space. So what this is going to do is it's going to, if we have something like ... title here with no space, or if we have something like ... space title here. In either case, it's going to take this entire bit, everything after the 3 colons. It's going to trim the white space off the ends, so any extra white space, in this case this, and then it's going to use this as the title. Is there a bytes.trim space? Oh, I need this to be a string is the problem. That's fine. So I'm opting to use the bytes.trim space so that I'm not... It really doesn't matter which way I did this. Eventually I had to convert one of those into a string. So I'm just going to convert the whole thing into a string. And then we should be good to go. So that should open it up, and it should parse it, return this block node, and then return the that it has children. So now if we get down here to continue... All right, so continue is parsing the current line and returns the result of parsing. Okay. I think what we need to do in here is we basically need to look at, I'm trying to read this all, but I think what we need to do inside of this is we need to look at it and say, if this is the triple colons that ends it, then we need to parse it and we need to tell it not to continue anymore. Otherwise, we need to tell it to continue and that we have children. So let me... how are we going to do this? Sorry. I think we need to start with line underscore is going to be reader.peakLine. Then we want to go ahead and check. So we're going to say if the length of the line is greater than or equal to 3 and bytes.equal the line from 0 to 3 is equal to the byte slice. So this would mean that our line starts with these 3 colons. I think that's enough for me to just call it a close. We might want to say the line has to be exactly that, but if somebody accidentally has a space after it or something, I don't want to stop that from closing it. In this case, I think this makes the most sense. So in this case, I'm going to do reader.advance, the length of the line, and then we'll do return parser.close. Okay, if continue has not been able to parse the current line, continue should return close. I want to say this is... I feel like this is worded really poorly based on the ones that I've... like the actual code I've looked at. I'm pretty sure we call close whenever we get to the end of this. So like when we have this all matching. Otherwise... constant for of type parser.state. I'm not sure why this is... Oh, it's just parser.close. It's not a function. That makes more sense. Yeah, okay. So, I apologize for that. I think this documentation here is like not completely accurate, because I've looked at a couple of other ones that do this, and let's go to gold mark. Let's go to extension. Let's go to, I don't know, footnote. And you'll see here, like in these continue ones, like if it's blank, continue has children. Yeah, like it looks like in the case where it's, I could be wrong. I'll come back and look at this in a minute. But I'm pretty sure the way this is supposed to work is that we close it whenever we're like, we've actually parsed it and we're done, we're ready to close this whole tag out. Otherwise, if we can't close it, we're going to go ahead and say return parser.continue or parser.hasChildren. And I will mention this. I don't know why they do this, or I know what it's doing. It's a bitwise OR, so like parser.continue might be a binary number like that, like 010, and hasChildren might be a binary number like 100. And by ORing them, you're going to get this number of 110, so that whenever you return that as a state, it can look at the bits in that and decide how to proceed. I don't like it, just in the case that I feel like we could have just had some different state objects to return that were a little bit clearer. Whenever you're ORing numbers together, I feel like it's just not what most people are used to, so it can be confusing for them. And the reason I'm doing continue and hasChildren is that if we're inside of an aside block and we haven't found this thing that allows us to close it, it's going to continue to be inside of an aside block. We keep doing that until we find a closing set of triple colons like this. All right. When we come to close, this is where I said we have a no-op. I want the no-op when we come to close, because after we read those 3 bytes, we don't need to do anything else. We should be good to go there. Okay. I think that's everything for this. So what we could do is come back here, and we can do aside block extension. So this will add it in here to our extensions. And if we look up here, we need to make sure it's being added in here. Then we have the aside block renderer. We might still get an error because we haven't implemented that. So we have the aside block renderer. We need to figure out how to implement this, and I'll tell you this one's a little bit more annoying, but if you dig through all of the code, you essentially have 2 things. You need this register funcs function, and what it's going to do is you're going to pass in something like the aside block node kind, so that thing that we're doing, and a function of some sort that's going to be used to render it. And then we need that aside block renderer render function, which is going to take in, I'm just going to autocomplete this, but it's going to take in something that has a buff writer, the source, which is like the source of the node in case you need to look at it for some reason. It's going to give you the node in just this ast.node version, and it's going to give you entering. Entering, what that's telling you is if you are currently entering the node for the first time, or if you are exiting the node and you need to render the exit of the node. And that's because if you have a block, you'll render the entrance of the node, and then it'll render all the stuff inside of it, and then it'll call this render again whenever we're exiting the node. So you need to know whether you're entering or exiting. In this case, you just get the Boolean for that. And then what we're supposed to return here is the walk status or an error. And basically we're telling it whether to continue on or whether it's supposed to stop parsing for some reason. I think in our case, we're always just going to continue. And it looks like the autocomplete actually did a good chunk of this for me. So yeah. Technically, the title is subject to code injection, but at this point, given that the blog posts are all going to be in Markdown file, like I don't worry too much about code injection with blog posts like this, because arguably we should be checking that source before we commit it and allow somebody to do it. We're assuming that the person writing these blog posts runs the site or like is not a nefarious actor, but we might eventually want to add some sort of checking here, which might, we could use an HTML template to fix this. For instance, I could do template.parse. I don't want to do any of that. I'm sorry, it's template.new aside.parse. Let's do an H3 title. Let's just do dot. We'll just do the whole contents. We'll close that up. All right, so TPL error is going to be template.new. And then we'll say if error is not equal to nil, return ast.walkstop error. And we'll say parsing aside template. And then otherwise, we're going to say error is going to be tpl.execute. Oh, the one thing worth noting is that this first line, what's happening here is we're taking the node that we have and we are converting it into our aside block type. And we're just assuming that it's going to be, if it had that type, it's going to be right. You could technically do an error check here if you really wanted to. In our case, I'm just going to let it be for the time being. The reason I say that is that like this really should not be called unless there's a really serious bug somewhere else. And even if we checked for an error here, there's no way to recover. Like this is a panicking type error of like we can no longer parse the markdown or render it correctly. Yeah, because we're always looking for that aside block kind. All right, tpl.execute. We execute it to W. If error is not equal to nil, we'll return ast.walkstop again and thump.errorf executing aside template. And then otherwise, we're going to put this closing aside. So let me go to the top, make sure we have the HTML template package, come back down here. In case that wasn't clear what was going on, I'm creating this new template, call it aside. I am throwing in all this. And the only reason I'm doing this is that if the title happens to have some HTML, so let's say the title is equal to some string like, I don't know, say it's an ahref to some crappy website or something. I don't know, whatever it's doing. It's something like this. We don't want that to happen. We don't want that to be rendered that way. We want to render the actual text of it. So we're using the template.html package to make sure that any cross-site scripting types, or not cross-site scripting, maybe that's what it is. Sorry, my brain is frazzled after doing stuff with this all day long. But it's going to make sure we don't have any code injection happening where people are trying to stick in HTML that we don't want to actually run. And I don't think it's a serious issue because this is like a blog engine, but again, we'll just add it because we can add it. All right, I think that is everything. We add this here. If we are not entering, we're going to close the aside. So if this is all working and we have it all rendered here, we should now be able to take this and render this aside and make sure it's good to go. Let's do go run command server.go. We'll come back here, we'll refresh, and we'll go to one of these. You can see here that this looks different, but we need to actually make sure, yes, it's inside of an aside block. It has a paragraph tag. But before I say for sure that this is working, I think it's worth coming back and grabbing a bigger block like this. And I'm going to put it in the how to boil eggs one, which, by the way, I wanted these to be list items. So I'm going to go ahead and put this in here. We can also have a block quote with code and bold text that spans multiple lines. All right, that should be enough of a test. So let's go ahead and stop the server, restart it just to make sure that we're all good to go. I'm going to go to the how to boil eggs one, and this all looks good so far, which is good. I want to go ahead and just click into this and make sure, yes, it is all wrapped inside of that aside block, which is what I was looking for. I might want to, let's make sure additional content is not inside the aside block. And if we do that, you'll see that all this is inside the aside block, and then we go back to outside of the aside block. Now, I will mention that with this right now, it's not being styled anything special. There's a couple ways we could handle this. One is to just put the classes in here. So I could just do a backtick for these two, and then inside of here, I can just use quotes now. So I can do class equals BG blue 100 P4. And now if I come back here and stop and restart the server, you will see that it now has a blue background. That's not the way I want to do it long term, because long term I'd like to be able to style this stuff separately, and having that hard coded into our parser is not the way we want to do it. So what we will do in a future lesson is we will look at how to take Tailwind, which we are currently, if I can find we're currently pulling in Tailwind via the CDN. We'll look at how to take Tailwind and actually build it locally and set it up so that it's correctly parsing that stuff, and we can set it up to take anything inside of a prose that's an aside, and we can apply certain styles to it that we want, so that there is the option for other people to sort of override that if they needed to. But I think for now this is a good starting point, and it shows that all this aside stuff is working. We have the renderer. Like I said at the start, I knew this was going to be a very long one. I also knew that it was going to get deep into the weeds with all this stuff that we have here. And you can even see here that I think when I first read this as we were going through it, I'm pretty sure I read it as it's stated, I think, but like I don't think the way it's stated is correct, because I've definitely written an extension before for Goldmark, and this was the way I expected it to be, but the comment doesn't make me think that's the case, so I'm not really sure what the deal is. But yeah, thanks for following along this long. And if you enjoyed this, I definitely suggest checking out some of my other courses and my other content. This one's a little bit rougher on the edges because I'm trying to just show the process of me going through building a project without a bunch of curation or anything like that. But if you go to like my paid courses, like my web development one, I spend a lot more time getting rid of all the extra stuff and just focusing on the content that you need to see. You'll still get to see my process of developing and everything, but you won't see me floundering around as much or anything like that. I'll sort of jump to the things you need to see, show you how I found them, and then move on to the next bit of code and explain it in nice detail. Whereas this is just sort of me exploring a little bit more than, it's not quite as curated or as clean. But yeah, thanks for following along.